Today we're going to talk about what it means to be a distance and the shortest distance between things. In the diagram below, there's a point and a line or line segment. Suppose I told you that that point was 3 units from that line. What would that mean, and how would you draw the 3 units away? So I would take the point and I would imagine how would I walk or shortly go from the point to the line segment. Starting at the point, what would be 3? Would it be from here to here? Would it be from here to here? No, it would be from here to here. The shortest distance between a point and a line is this distance here, and it is the perpendicular distance. This would be 3 units away. So definition 1, the distance of a point to a line is defined to be the shortest possible distance. And that shortest possible distance is also the perpendicular distance between the point and the line. How does this relate to arcs and chords? Well, if 2 arcs are congruent, then let's see what that would look like. So let's draw an arc here, an arc here, and let's draw another arc here. And what we're saying now, we're saying that arc AB, which is the distance along the circumference of the circle, arc AB is congruent to arc CD, which is this arc here. Well, let's go ahead and draw in the distance between the point and the chord. And we know that that's the perpendicular distance. Let's draw in the distance between the point and the chord on this one. And we know that those are the perpendicular distances. So, what do you think that means in the construct of this picture? What do you think that means if I call this E, F, and let's call this circle X? Well, one thing that would be true is the chords, if 2 arcs are congruent, then the chords that contain them are congruent, which means that CD would be congruent to AB. So again, up here we decided that arc AB is congruent to arc CD. That was the theorem 1 starting. The other thing that's true is that they're equidistant from the center. So the chords are equidistant. From the center. So that would mean that the distance from XF is going to be the same as the distance from XE. In this diagram over here, let's draw a picture of, let's just use this blank diagram to draw a chord that's not the same length as another chord. So if I draw this chord here and I draw this chord here, it's clear that the arc created by this chord is going to be much smaller than the arc created by this chord over here. So if they're not congruent, if the chords are not congruent, if chords are not congruent, not equal, then one is going to be longer. One arc will be longer. Theorem number 2. The radii that bisects a chord. So actually, let's just make another chord here. And let's make a radius here. And let's think about this picture right here. So this radii bisects a chord. If it bisects a chord, that means this would be the picture. So what would that mean? A radii bisects a chord. What would that mean about this distance, this construct? Well, if I was to draw in the radius of this triangle, or the hypotenuse, well, actually, not necessarily the hypotenuse, but these are just the two radii of the circle. And if you look at this picture, we have a side. We know that this side is congruent to this side, and we know that this side is congruent to this side because the radii are always congruent. So these two triangles are congruent because of SSS, which means that these two angles are congruent, but they also add up to 180. So that would mean these would have to be perpendicular. So if a radii bisects a chord, it's also perpendicular to it. And the converse is too. The converse is true. The radii that is perpendicular to a chord also bisects it. So this is also often stated as an if and only if. A radii bisects a chord if and only if it's perpendicular to it. So on the next page is some practice. And let's do the first one together. So in this diagram, the circle has a chord of 48 units across, and it has and it's 7 centimeters away from the center. So that means this distance is 7. Well, the shortest distance between a point and a chord or a line segment is its perpendicular distance. So we want to find the radius of a circle, so we can just finish off this and do Pythagorean theorem to find the radius r. So the radius r, this is a perpendicular, would be r squared plus 7 squared equals 48. Oh, not 48 though, right? It's definitely not 48. The whole chord is 48. And this is an isosceles triangle, so half of the base here is 24. So you can do the math out to complete example 1. Example 2, let's see what they're asking for. A chord is 2 centimeters away from the boundary of a circle, and the circle has a radius of 6. So that would mean if this whole thing is 6, that would mean this distance has to be 4. Find the length of the chord. Okay, well, we have one radius drawn in, and when in doubt, draw in radii. So if I was to draw in this radius here, we're also told that this is, it's also 6. So you can find the length of the chord here by finding half the length of the chord using Pythagorean and doubling it to get your answer. So why don't you finish number 2. Number 3, in the circle to the right, measure of arc AB is 86 degrees. Find x and find y. Well, let's see. We can find x because, let's see, if we know that this is a right angle here, and this length of the chord is 5, and this length of the chord also has to be 5. So that would be one part of the answer. And let's see. So this whole thing is how many units across? This whole chord here is 10 units across, isn't it, if we call this chord CD? Well, CD is the same as AB. So what do we know about chords that are congruent? They bisect, they create congruent arcs. So in other words, arc CD is also going to be, this whole thing is also going to be 86 degrees. So again, we can find y by taking half of 86 degrees. Half of 86 is 43. So that would be the answer to number 3. So for the rest of your evening, please finish this arc chord worksheet as best as you can, and we'll talk about the answers in class tomorrow. Next class.